Hello and welcome to this repair tutorial, and today we're going to be looking at an Arcam Alpha 7R series amplifier. So general specifications: power output from the amplifier is 40 watts per channel into 8 ohms. Frequency response is 20 Hz to 20 kHz. Total harmonic distortion 0.01%, which is typical for this range or series of amplifier in terms of price point. And then input sensitivity for the moving magnet input, you're looking at 3 millivolts and 275 millivolts for all of the other line inputs. And it also supports a preamplifier output, which is 0.5 volts, and input impedance there would be 4 to 16 ohms. So that's common where you want to also provide a drive into another amplifier. And then standard dimensions for an integrated amplifier: so height 85 millimeters, width 430, and then the depth is 330 millimeters. And slightly lighter than many integrated amplifiers, so just approximately 4.5 kilograms in total. So this amplifier came in from a customer who had contacted me via the YouTube channel, which, you know, a lot of the repairs that you see come via that, which is great to see that people are able to, you know, source specialists who are able to repair sort of older equipment. Sadly, a lot of the repair shops have closed down. Economical reasons for sure, and those technicians may be, you know, operating maybe in a home workshop, or in some cases have just gone out of business completely. So, you know, that's sort of unfortunate to see. So as with all the Arcam series amplifiers, you know, always a pleasure to work on. And this amp had an issue where the owner reported that the amplifier had no audio. When you powered the amp up, you had the power LED not indicating green. It should, after about 3 to 5 seconds, you should hear the speaker protection relay operate, and then the power LED would then change from amber, and it should be solid green, but not in this case. So the first thing really to check is to what's going on with the microcontroller, because the microcontroller operates the mute circuit. It will also send the command signals then to the motor control driver IC, which is shown in the video. But of course it requires a common power supply. Now the transformer supplies 9 volts AC to this part of the circuit, and then the first thing that I'm measuring is I'm going to measure D902, which is shown, and that is a 5.6 volt Zener diode. Now I know from experience that over time, and this isn't all of the amplifiers that you see of this sort of time period, D903 can start to drift, and what happens is it drifts high. So instead of it being 5.6 volts, it sort of drifts high, then up to almost like 7 volts or slightly higher. And the problem with that is there's no additional protection circuit for the microcontroller. And the microprocessor, you know, can't receive any voltage which is greater than 5 volts. If it does, then it destroys the micro. So it's not sort of uncommon that you'll see on some of the repair backdrop tutorials where I advise, you know, I needed to change Z901, which is the PIC microcontroller. But thankfully for this amplifier repair, it had nothing to do with a 5.6 volt D902 going high in terms of voltage correction. And so the microcontroller wasn't the issue. When I did the voltage measurement on one side of R901 as shown, which is a 1 ohm fusible protection resistor, the voltage was present. But as soon as I go to the other side, then there was 0 volts or just a few millivolts. So straightforward then to depower the amplifier and then just do a resistance check, and sure enough, D901 was open circuit. Now when you look at the schematic, what you can see is that the resistor is used as a protection resistor because it also provides the power then via this rectified 9 volt AC voltage to the motor drive on the back of the potentiometer for the volume control. So absolutely nothing wrong with the design, but because the resistor also as well was not burnt, or it had no sort of heat related indication on it, you know, I'm very confident there that the resistor has not failed because the motor has drawn excess current or there's any other sort of underlying issue. So once the resistor was replaced, again with a 1/4 watt fusible resistor, very important, ensure that you fit the correct type of resistor after that, because it is a protection component. As soon as that was replaced, powering up the amplifier, 3 or 4 seconds later, you heard that nice click come from the speaker protection relay, and all was good. But of course, I'd also made the voltage measurement on the other side. And then what I also do, again based on experience, is I just check to see what's happening with D902. And D902 was absolutely bang on, just slightly under 5.6 volts, so again no concerns. And then I also then verify that the voltage to the PIC chip is 5 volts or just under, and it was coming in about 4.92 volts slightly, and that's fantastic, right? So I'm never in a position then where it's going to be overdriven during that test phase, and there's no underlying issue there. And then because this was both a repair and a service, which is always the case with any amplifier that comes in, it's a systematic routine then of doing all of the other remedial work which is associated with this age and type of amplifier. So you'll hear this repeated on many of the audio tutorials. I'm going to look at the main amp board, and there will always be dry solder connections. So starting from the left, working my way across, I will reflow all of the RCA input sockets. I'll then reflow the solder connections on the Mosfets, also then on the speaker terminals if required, but not always. Then I'll resolder the Euro input main socket, work to the front. I'm going to resolder the connections then on the headphone socket, often dry joints on there, and then I'll work my way along the user controls. So I'm going to resolder the balance control, treble, bass, also check the volume control, and then I arrive then at the input selection switch, remove it, and here there were dry joints on the pins, very, very common. And then I can then take that switch apart. I can clean all of the contacts internally with a fiberglass pencil, and then I can clean or just put in there De-Oxit lubricating grease to make sure those mechanical parts run smoothly, and just make sure that you have the orientation correctly, right? There's nothing worse than you get it the wrong way around, and then when you come to refit the switch in terms to reassemble it, you get it out of alignment, and then you have issues then with the switching contacts then. So once then installed, make sure that you push down on the top of the board to make sure that you get all of the pins right the way through, and then you can resolder it in place. Don't be skimpy on the solder. Make sure you put a reasonable amount of solder on there. You want to have the longevity then to the repair. And then what I also do as well is I'm just cleaning the user controls, all those switches and potentiometers in the headphone socket, just clean it up with De-Oxit. Make sure that there's no sort of problems or anything like that. Make sure that they're all nice, clean, and then smooth. And then I also replace the speaker protection relay, which is the OMROM relay that you see. Some people will sort of say, well, is there really a need for that? It's just looking at the age of the amplifier. What I don't have is how many operational hours the amplifier's been used for. I don't know how the environment that it comes from. So it may well be that the user has used it for an extensive time period or less so. But these switching contacts over time will always become oxidized and go resistive. So what I wouldn't want to do is return the amplifier back to the customer, and then maybe in a year's time, due to contact wear on the speaker protection relay, the customer then has the inconvenience of having to return the amplifier, just for that single repair then. And final stage, of course, is just to check the millivoltage. One, I think it was the left channel, was slightly higher, about 3.2 millivolts. So both the left and right channel MOSFET output bias was then set to approximately 2.2 millivolts. And then it's a case of leaving the amplifier then on a functional test. Once that was then completed, everything was all good. And final stage then was just the cleanup of the amplifier and then return them back to customer. Okay, so that brings us to the end of this repair tutorial. So again, I thank you very much for stopping by. And if you have any questions, by all means email to audioamplifierservicing@aol.com. I'll be more than happy to contact you back, and I'll provide any insight or any information. All right, so until the next time, I wish you all the very best and take care. Bye-bye.